So I'm going to show you guys how to solve exponential and logarithmic inequality in this video. So the method is kind of the same. So that's why I will just use the same step as I was solving exponential and logarithmic. Maybe just a domain related few issues, then I will show you that in this video as well. Okay, so first we have to isolate the exponential, right? That's how we were working with the exponential equation. So I will just add 7 to both sides. Less than equal to log 19. And then I can just, I'm sorry, not log, you have like 19. So cut back. This is just 19. And now I can apply log to both sides. Logs to both sides. So this will change to log less than equal to log 19. I'm able to do that because both sides are positive. Otherwise, I cannot do it if one side is negative. So then take this power and put it right here. So x times log 2 less than equal to log 19. And then divide both sides by log 2. And I can still do that because it's positive, which is the same as log base 2, 19. Okay. So I can compute this number if I want the numerical answer, or I can just leave it like this and write my answer. So the solution is really just going to be from negative infinity to that number because x is less than that number. So this will be log 2, 19. And then I can just leave my answer like this. Okay. So that's one example. Now, solving logarithmic inequalities. Well, the steps are kind of same, I said, but let's just go over it a little bit. Solve original inequality using the same method as logarithmic equation, and you can leave your answer in log form if you want, or if it's needed, convert that to a decimal, and then set answers of each individual log bigger than 0 because input of the log has to be positive always, and this is like the restriction, the most restrictive form that we need to put this in. Okay, and then you check the intervals if uncertain of correct intervals. So at the end we always check it. So this last step was always checking it. Okay, so let me show you guys on this example. So you have a single logarithm on both sides. So how we were working with the equality, if you have a single logarithm, you can just go ahead and cancel them out, right? So I can do this. I can just go ahead and cancel both logs. Then I'll just end up with input there. And then I'll solve this. So this is 5x minus x bigger than 7 plus 1, which is 4x bigger than 8. And divide both sides by 4, x bigger than 2. X bigger than 2 needs to be checked, right? Because, like I said, we could have a problem with the inputs. Now, x bigger than 2, well, you can pick, for instance, 3, right? 3 plus 7 is positive. 5 times 3 minus 1 is positive. So 3 is sort of like this, not the smallest, but one of the number here I could check, right? So since it satisfies for this number, then for any other number, it's going to be fine. So therefore, the solution is just going to be x bigger than 2, so that's 2 to infinity. So that's one thing. And now here I have multiple logs on both sides, so I can just do this. Using the properties, I can turn this into a single logarithm, and because it's minus, I can just divide inputs. Then I can just cancel this out. So then x divided by 9 is less than 3. Then if I multiply both sides by 9, I can cancel out the 9, so x is less than 27. Again, I have to check this. X less than 29, well, x could be negative, but I can't plug a negative number here because x is strictly bigger than 0, right? So then I'm going to stop it at 0. I'm not going to plug anything 0 less than 0. So then the x will have to be between 0 and negative 27. So therefore, it has to be 0, 27 included. So that's the solution. Okay, now let's look at this example. So again, I'm going to convert it. So I can do this, see, 5 5 to the 2 input, I mean less than input because now I have to follow the sign. 3x plus 1 is going to be less than 5 squared, which is less than 25. Keep solving it until you find x less than 24. If you subtract 1 divided by 3, x is less than 8. Okay, x is less than 8 can include negative numbers too, but we don't want the negative number, right? So we want input to be bigger than 0 always. So input is 3x plus 1, and I want this to be bigger than 0, which is 1, x is bigger than negative 1. So I want the x to be bigger than negative 1. So x is bigger than negative 1/3, and it's smaller than 8. That's going to be the solution, and you write it as an interval. This will be the solution. So the most restrictive one is going to be the solution always. Now let's take a look at this example. Again, I have to make this a single logarithm. So I'm writing it as 8x minus 3 times, because it's a plus, so it will turn into multiplication, less than 1. Then again, 8 to the 1, so x minus 3 times x plus 3 is less than 8 to the 1 is 8. So now distributed, so x squared plus 4x, so I'm foiling it, negative 3x, negative 12 less than 8. This is x squared plus x, and then subtract 8, that will be negative 20, smaller than 0. And now factorize this, which is x, this will be 5 and 4, this is plus, this is minus, less than 0. So it's like solving nonlinear inequality now. And then to solve this, remember, we just set each factor to 0 and put the numbers on the line, negative 5, this is positive 4, and then we test it. So if I just pick, let's say 5 and plug it here, that's positive, it's not negative, so this doesn't work. And here, let's say if I pick 1 and plug it in, it's going to be negative, so this will be yes, this will work. So negative 5, and then you pick something here, let's say negative 6, if you plug it in, it's not going to work. So this could be the solution, but I have to check again, right? Because anything between negative 5 and 4, you could pick negative 4. See, if you pick negative 4, it's not gonna, this is not gonna work. So x minus 3 has to be bigger than 0, which means x is bigger than 3. X must be bigger than 3. And here, x plus 4 is bigger than 0. X must be bigger than negative 3. So I'm gonna find the most restrictive from all of this. Right? So let me put it here. So I have negative 5, between negative 5 and 4. Let's say this is negative 5, this is 4. So this is one of the interval I got. And then now I have bigger than 3. So 3 is right here. 3 is going to be right here. Bigger than 3 is going to be all of this. And then bigger than negative 4. Well, negative 4 is right here. Negative 4 is right here. So it's going to be bigger than negative 4. So I'm going to find the intersection of these 3 things. So basically 3 colors, right? 3 color is right here. So basically it's going to be 3, 4. So the solution has to be between 3 and 4. So the most restrictive one that you can possibly get. Okay, and let's look at this one. So this C, you're going to convert it, right? So you're going to do 5 to the negative 3 equals the input. So it's x less than 5 to the negative 3, which this will give you x less than 1 over 5 to the 3, which is 1 over 125. And the input has to be positive, of course. X is bigger than 0. Now I'm looking at 2 things, right? So now I'm looking at 2 things. X is bigger than 0, and x is smaller than this. So x is bigger than, sorry. X is bigger than 0, 0 less than x, and x is less than 125. So then your solution is 0 and 125. So that's basically it. So you see, it's very similar to solving exponential and logarithmic equation with taking the most restrictive interval possible.